Hello there, 8th graders. This is Mr. Kashi speaking. As you can see, I can't be there today, but if you've been in my class before, you're used to these videos. I'll go through the lesson here just as if I were there. What we're going to do first is we're actually going to have two videos today. The first video, we're going to go through 3 homework problems that I kind of chose for a specific reason. They're a little bit closer to the lesson that we did yesterday than the others. And then the other video is going to be going through some notes and some practice problems on 8.2.3. Okay, and so that is our schedule for today, and hopefully you'll get some work time on that worksheet, that 8.2.3 worksheet here by the end of the hour. So the first problem that I want to do is problem 42, 8-42. If you don't have that, please obviously pause the video and make sure everybody has a chance to get that out if it hasn't been passed out already. So once again, with this video, you can go ahead and pause it, whatever you need, if you need more time to jot something down or anything like that. So problem 42. A homeowner must reduce the use of the home's electricity. The home currently consumes 25 kilowatt hours of electricity per day, and the homeowner must reduce the use by 20%. They must reduce by 20%. Find the amount of electricity that will be used after the reduction in two different ways. Using two different scale factors. Okay. So we have 25 kilowatt hours that we're using right now. We need to reduce it by 20%. Okay. I will start with one way, and I think this is the way that a lot of you would probably prefer to do it. Please excuse the sloppy handwriting. I have to do it with the computer mouse. So we have 25 kilowatt hours, and we want to find what 20% of that is. So 20% in decimal form is 0.2 or 0.20. Okay, and if we do 25 times 0.20, we get 5 kilowatt hours. Okay, 5 kilowatt hours. That's how much we have to reduce. That is the 20% of the 25. So once we find out how much we have to reduce, a lot of you might be able to just do this in your head, obviously, and we would just take the 25 that we have, subtract off the 5 that we need to reduce, and we get 20 kilowatt hours. That would be our answer. Okay, 20 kilowatt hours. That's what we have to reduce down to. Okay, so we're at 25. We have to go down to 20. And that would be a reduction of 20%. Now, what I was trying to show a lot of you yesterday and wasn't really working out too well is the second way. And like it says up here in the problem, we have to do it two different ways. So what I would like to do is I would like to say, all right, well, we have 100%. And we have to reduce it by 20%. Well, 100% minus 20% would give us 80%, obviously. Okay, so 20, like we were talking about yesterday with sales and things like that, 20% off would be the same thing as 80% of. Okay, and so I prefer to do it this way. You get, in my opinion, you get to your answer a little bit quicker. If you would just be able to do all that percentage reduction in your head and know that you're going by 80%, here you would take 25 kilowatt hours and you just multiply it by 0.80 or multiply it by 80. So now we're actually finding out what is 80% of 25, and that would go straight to our answer of 20 kilowatt hours, just like that. So two different ways of doing it. You can reduce the percents first and then multiply, or you can multiply and then reduce. The first one is multiplying by a decimal and then subtracting the actual numbers. The second way is subtracting the percentages, turning it into a decimal, and then multiplying second. So I'll give you a little time to get that on your paper. Make sure that we've gone through that. Both of them have to be on there for credit. So go ahead and pause the video if you need more time. I am going to move on to that next question. Okay, so let's go on to problem 44. Study the following division problems and the diagrams that represent them. Answer the question below each diagram. All right. When we divided fractions in 7th and even earlier on this year, we kept going back to this drop flip switch. I'm hoping these diagrams are going to help you out quite a bit, and a lot of you might even learn something that you never knew about dividing fractions here. Okay, so we have 8 divided by 1/3. Let's just look at this problem for now. 44a. 8 divided by 1/3. Okay, and so basically we have 8 rectangles here, and we're splitting each one of those rectangles up into thirds. And basically they're asking how many thirds do we have in 8? Okay, and so obviously you can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. How many thirds do we have? We have 24. Okay, now a lot of you, this is just a visual representation of, well, if we had this 8 divided by 1/3, a lot of you are used to the drop flip switch. Well, what is 8 times 3? 8 times 3 is 24. Okay, so the drop flip switch method is just kind of a shortcut, but it doesn't really help you understand what the concept is. This diagram is really good, does a really good job of showing you the actual concept. We have 8 rectangles, and we've split them up, each of those, into thirds, and then we just count the amount of thirds there are. So 24 would be the answer to that problem. 44a. So we're going to use that same strategy over here for 44b. Okay, we have 8 divided by 1/4. Well, we still have the 8 rectangles. How many fourths are in 8? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. If you counted them all up, we have 32 fourths, which, again, if we had 8 divided by 1/4, and we did our drop, flip, switch, 8 times 4 gives us 32. Okay, so this is the shortcut, but this is the concept. And I think this is much easier to see when we actually draw it all out. When it's drawn out for us, it doesn't take a whole lot of time to see, oh, well, each one of them is split up into fourths. We just count how many small rectangles we have now instead of the big ones. If each of them have 4, well, 8 times 4, 32. And that is for 44b. I'll give you some time to jot whatever you need down, and we'll go over one more here before we wrap things up for this homework assignment. Alright. Go ahead and pause the video if you need to, but let's go on to problem 45. The table at the right shows speed limits in foreign countries in kilometers per hour. Obviously, a lot of countries don't do miles per hour. That's customary or English system. They go by kilometers, and so they measure their speeds in kilometers per hour. That's what happened. That's in Canada and in Mexico. Obviously, too, the two countries closest to us. 1 kilometer, though, is equal to 0.6 miles. Okay, so a kilometer is 60% of a mile. What are these speed limits in miles per hour? All right, well, 60%, so 0.6, and we're talking about, over here, we're talking about hundreds and 110, okay? Not that it matters a whole lot, but what they call motorways would be like what we call freeways. And so basically what you have to do is you have to multiply each one of these speeds by 60%. So we just basically do 0.6 times 100. Well, 0.6 times 100, you can use your calculator if you like, but that would just be 60 miles per hour. That's what Australia would go on country roads. Okay, on motorways, then you would have to do 0.6 times 110 and see what you get. 0.6 times 110, we get 66 miles per hour. Okay, so what we have to do is you just have to go through, well, obviously the 100 here we've already done, but you have to go through 120, 96, 112, 90. You have to take all those and you have to multiply them by 60%, or you have to multiply them by 0.6 to find out what their actual speed limit is in miles per hour. And these are just the two that I'm going to do here, so you guys can go through and do it for 120 and 96 and 112. Go through the problem and do it for all of those speeds. Okay, we will have another video up here shortly, just dealing with the notes for today.